So today is Python library. Libraries are collection of modules and functions. So when we want to read a book on different subjects or different topics in a particular subject, then what do? We go to our library, college library, and take out books one after another and we go through them. Because something ready-made is available there. So same thing happens here in every high-level language, and in Python it is extensively, I can say it is an excellent library provided by the Python. So in Python also, same thing happens. They have a library, but this is a software library. So here all the functions, all the modules, packages are being kept and which are being routinely used by us. So for those small things like calculating a sine function of value or any such kind of operations which we want to perform, calculations we want to do. So in that case, we don't have to write long codes, and rather there are ready-made programs available. They are already being coded and they are available for us. You have already seen how function works. So in a function, what happens? We have to pass the parameter. So the real parameter we pass to it, the dummy one holds it and computes everything and returns the answer to you, right? So at the same place from where it has been called. We do not even experience that what is happening beyond the whatever we are seeing beyond that. Underline what is happening, we never know. Only we know, we look at the answer, okay, something has, value is being put at that particular place which has been assigned. So these are for helping us so that we don't have to write such codes again and again. Suppose, for example, if you are writing a program in physics where at least 8 to 10 times you need to write you need a factorial value, and there is no function available which will calculate factorial value. So what will you have to do? If there is no function kind of thing is available, this feature is not there, then we will have to write same code again and again. So that we don't have to do, because we can write functions, and functions are those codes which are written once and can be called again and again as many times as you want. So if you want to calculate 5 factorial, just pass the factorial. Suppose if factorial is the name of your function, then inside in front of factorial in round parentheses just write 5. So this 5 number will be taken and factorial of this will be calculated by the code. So computer doesn't do anything on its own. It is not a magic machine. It does it magically because we have made the provision at backside, at back end, like director in picture. So they are at the back end. We never see them. We just look at the performance on the screen. So same thing happens here. The codes are being executed and the result is computed, then only it is given to you. But you don't have to worry about it. You don't have to write it. So this is how function works. So we can design our own functions as per our need. We can, but many of the items or many of the routine parameters are there which we need on daily basis while working with scientific applications or mathematical or statistical data if you are dealing with. So you need to calculate them again and again. So all those they have collectively thought of, and they have collected those codes together and with different names, of course, and under one NumPy. Suppose if NumPy is there, under that all numerically, whatever you need for numerical applications, all those libraries, in this library, all those functions are available. So this is the concept of a library. So you can just use it and be happy. While writing the program, you don't have to distract yourself because we have something in mind. And we know this is are the routine things which we have to calculate, and we know them very well how to compute. So why to waste our time and energy in writing codes for all of them? Instead of that, if they are readily available, just use them. Pass on your value, it will compute and will give you back. So this is how we can focus on our task 100%, and we can design a very good program. So this is how it helps you, the libraries. Now there are various types. these are typically pre-written functions, classes, constants that are useful for performing calculations, simulations, analysis related to various branches of physics. So these are not only for physics, but especially I have mentioned here because you people are going to deal for your physics problems. You are going to use them for solving your physics problems. So they are equally useful for any problem related to the physics. Now, types of Python libraries. So it boasts of a vast ecosystem of libraries catering diverse programming needs. It caters everyone. It is ready to serve everyone for almost, you just name it, I want this kind of function, ready-made function, and it is there. So this is how it is helping us. Now, first is numerical computation. Now see what the name is given. Name is given like the first letter it has taken. So it is numerical. So NUM, and you must have noticed the first letter of NUM, it is always capital. And then for Python, PY. So P is capital, but there is no space. Okay. So MY is NumPy. We call it as NumPy. So numerical computing, it facilitates efficient numerical operations, arrays, any other mathematical functions. So it is a fundamental library for scientific computing in Python. So more or less what I find is the NumPy is also because mathematical calculations are needed in scientific applications as well. Not only mathematicians need them, we people also need them drastically to solve our problems. So they are available for all these scientists, and it provides powerful array and matrix operations, linear algebra functions, random number generation. Random number generation is we need for game applications. So whichever game you might be playing or you might have seen, so they are prepared. So in each and every random number generation, where this particular function is being used, and all other mathematical tools. So use cases where they are used extensively. So scientific computing simulation, we have already seen. Linear algebra operations, okay, that has also been seen. Signal processing like sounds, so sound signals or any other signal images signals like, so for image analysis and signal processing and the working with large data sets efficiently. Now, you know, when we are going for AI applications, your data set for teaching will be very small, but you can imagine that how big data set it must be to, which is needed to train them to behave like as a human mind. They should, computer's brain should behave like our human mind, and we need to train it in a way. And these data sets are, they come for our help. We put everything in our data set and then train them. Okay, this is being calculated like this. And then after that, we give our sample data, and whatever result comes, then the predicted one and actual, they are again meshed. So there should be very, very little, tolerable kind of difference should be there between them. Then next is SCI-PY. So again, scientific. So from scientific, it is taken SCI and computing. So PY is there. So SCI-PY, sci-fi. It provides advanced numerical algorithms for optimization, integration, then interpolation, solving differential equations also it needs. Then algebraic manipulation, calculation, everywhere we need them. So basically NumPy and SciPy, they are being used by all the mathematicians, statisticians, and all the scientists all over the world. Functionality, of course, it complements, and NumPy provides collection of algorithms and functions for scientific computing and engineering problems. Offers a function for optimization, interpolation, statistics. We have seen signal processing also needs functions from SciPy. And used cases are more or less same, solving differential equations, then for integration, optimization problems, signal processing, image analysis. Our NumPy is also needed for this, and the scientific and engineering computations. Okay, and this was the symbol for SciPy, and this is for pandas. Now, data handling. What is data? You just imagine, close your eye and just imagine throughout the day, whatever you were doing has been converted into data. So we are always dealing with the data. Data is not only numbers, it is textual data, it is image is also data, everything surrounding us is a data. So I feel like telling Aluwalia sir is a very good artist. So sometimes I felt like when I was preparing PPT, I felt like requesting him to prepare the data surrounding a human being. Like it is, we are being bombarded by data throughout data, right? Now, pandas, they extensively used in AI applications, and for computational physics also they will be used. So pandas, data, they are used for data analysis and manipulation. So it enables data manipulation, analysis, and it is crucial for organizing experimental data or simulation data in a tabular format. Now here comes the point that how do you arrange your data? How do you arrange your data? One thing, yes, okay, if you are preparing a attendance sheet, suppose, of our student, then take a name, somewhere I'm writing the ID number, somewhere address, somewhere biodata of student. So haphazardly, I am collecting the data and putting it. So this is unordered data and is of no use. So for computers, you have to bring unordered data into ordered format. And from bringing it into ordered format, so we do it in our daily basis. Even if you are writing the bill, what will you do? First the serial number, and then particulars, and then the rate of this, and the total cost, and then you will calculate. So there is a systematic format. If you are preparing a result, you will write the name of the roll number of the student, the name of the student, and then the marks obtained by the student. So this way you are going to write. We are never going to write the marks obtained by the student at first, followed by name, and then followed by ID, or vice versa. No, we follow a systematic rule, and it is in our mind itself. So our mind has been trained automatically for this, because we have seen, either we have learned from others doing it this way, or someone has taught us, maybe our teacher or some of our mentors might have taught us. But we know it, that how it should be done. Small things at least we do in a very systematic way. And when we put our data in this way, and when you put it in the computer, when you are able to store it in a similar fashion, then it is nothing but the data set or database or data file. And there comes data analysis, because simply putting data somewhere has no meaning. What for you are putting there? Or you want to calculate average marks obtained by the students, or you want to arrange them in sorting order, maybe in descending order of marks, so that the merit list could be generated. So for all those purposes we need. So data analysis and manipulation, the data files are there, and for doing this data analysis and manipulation, pandas help us a lot. Rather, panda helps us. Without panda, we are nowhere. We will have to write each and everything using, Python program, in keep in mind, and then putting code in action on paper, and then, or maybe if you are expert, you can directly put it in the computer, but you will have to make a big programs for them. So panda is there, don't worry. So it is a high-level library built upon on the top of NumPy, specifically designed for data analysis and manipulation. It offers powerful data structure like data frames. Now I will talk about data frames. Now, when we say structure means something very organized. Structure means something very organized. So data frames are nothing but, please don't get afraid of these words, it is nothing but tabular data. Now, how easy it is to write everything in tabular form, you know it very well. Na? Physics, we have been doing since, we were learning it, and those who are learning. Whenever you take observation, you just can't write observation here and there. You are being asked by your teacher to make columns, and suppose for kinetic energy, the easiest example. So kinetic energy, you need mass and velocity, so you will make serial number, then mass, velocity, right? And then you will go on putting the observation one after another. And for finding the result, you will add one more column, kinetic energy, and there you will write half mv square. And below that, you will compute these data and put the result, right? So this is what we do. So this is data frame. So just think of Excel. Now in Excel, you can see the structure made by you, on a screen itself. So this is the best thing which I can suggest you, that just remind your Excel file. In Excel file, what do? Do you start entering data randomly, or you first prepare your data frame there? You first prepare data frame. Here I will write the headings. So that column, that row you book for it. Below rows are for putting data under it. Then you make columns. How many columns will I need for putting my data for this particular problem? So that you do. So like this, it goes on, and after preparing the whole sheet, it becomes your data frame. It is ready to accept your values, your observations, or whatever data you have, it is ready to get it. Okay, so this is what is data frame. It is tabular data, and series is very simple. It is one layer. So loading use cases. So Pandas helps us in loading the database, then cleaning, transforming, analyzing, data wrangling, exploration, time series analysis, merging, joining, and many more. Okay, these are few I have written here. So this is all about the data handling. And now comes matplotlib. You know about it because Ritika already has taken matplotlib. Now, under this library, it is a versatile library, no doubt about it. And it is used for creating static, animated, interactive kind of graphs and visual representation. And it provides various wide range of plot types, like line charts, you can draw scattered, then histogram, all you can plot using this because the functions are available for them. Then Seaborn, it is built on the top of matplotlib, but we are not going to discuss in detail about this because these are for creating high-level maps which are required for statistical manipulation. So statistical graphics people, they use it. All the statistic people use it for plotting box plots and violin plots and then heat maps and all that. So matplotlib is a versatile, powerful library, and it offers wide range of functionalities to create various type of plots. So let us plot some. So this is the symbol for matplotlib. And okay, we'll discuss functionality and then we will jump to the programming part of it. Functionality, so of course 2D plotting, customization, subplots, interactive plots, exporting, 3D plotting, animation. So when you will become expert, you can enjoy preparing small programs for animation base. So it is fun to make them. Now this is the program for, okay, this is the program for line plot. Now today you will be able to understand easily because basic use case for line plot to visualize trend over time or a continuous data set. So first, what we have to do is import. What will you import? Your library. So our respective library is matplotlib.pyplot because we want to plot it as PLT, and PLT is an alias name. Now alias name, now you have understood it, but again I would like to recall it that alias name means like you are being called at Mintu Chintu or Mini Baby and all those names at home, but you are same person being called by your actual name by others, right? So things are same, but the alias name is for simplicity because all big names, instead of writing that, you can make a alias name and later on just rename. It is like renaming. So actual name is there, but you have renamed it, and now this alias name you can use it in your program. So PLT is the alias name, and X has these numbers, X-axis, Y this, then plot, PLT.plot. Now with PLT, we will call all our functions. So PLT.plot, and to this plot function, you have to send 3 parameters, which are they? One is X, another is Y, and third one is marker. Now you know marker. Either it is 0 or cross or any other you can put. But generally we don't use any other character. But you should not rely on such things. I mean, while practicing now, you should try to write their hash. Why not to type some other letter there and see really it happens or not. Just don't rely on your, I mean, from one who has, you have gained this knowledge. You should try and see it, that what will happen if I put hash here. It will be printed, but generally we use 0 and cross. Then plot title, plot dot title. Now in this you have to supply the title name and plot dot plt dot x label. So you have to write the name of whatever name you want to write here, that you can write. For simplicity, I've written x-axis, and whatever you will write for y-axis, then you can write that. It will, and then plot dot show. So this is for displaying the graph. So I have already pressed the button, so graph has been displayed. So no problem. You have already seen this graph yesterday, and now comes next. This is for plotting scattered graph. Now you can see the only change I have made is plt dot scatter. Every time then the scatter part title and these things you can change, but the basic, the technical change is here. Instead of calling that function, I have called plt dot scatter, and this will help in, yes. So this is being plotted, okay. Then next, bar chart. So often we need bar charts to be taken into our as an output for displaying the result, for depicting our output. We need bar charts many a times. So again, the only difference you can see is plt.bar. But here categories, values, and this is no more x and y axis now. So this you have to keep in mind that it should be sensible. So like in this example, I've taken categories as A, B, C, D, E, and the values, respective values are 3, 7, 2, 9, 12. And color, of course, red, any color you can choose. I have chosen violet being my favorite. And then title, you can write proper, X label, Y label, and show. So this is the bar chart, right? So categories on x-axis, values on y-axis, and properly labeled A, B, C, D, E, 0, 2, 4, 6, 8, 10, our scales, and then the bar chart is. Okay. And the next is, the last one is histograph. Of course, you won't be using it, but it's fun to look at its output. So the random dot random, so random is being called, so purposely I have used this. And then this you will have to just guess, and then, oh, this is the histogram. Okay. Let's move to next. Okay. Now, this is for astronomy, astrology. So astropy, this is for astronomy and astrophysics. These are the tools used by them for celestial mechanics, coordinate transformation, and astronomical data analysis. So we have one expert in IIPT. Exactly, I'm unable to recall their names. There are very few astronomists, I mean physics, astrophysicists. So astrophysicists use this. And then PyTS tool, so focuses on dynamic system and differential equations, aiding in physical systems and complex dynamics. And then TensorFlow and PyTorch. Now, TensorFlow is extensively used in machine learning. So we are going to use it, I mean, you are going to use it with Aditya sir when he will start machine learning programming. Okay. So 2 days after, I mean, tomorrow and day after tomorrow, after that, we will start with the machine learning. So you will be using it, TensorFlow. And functionality, they are popular libraries for deep learning and machine learning. They provide framework for building, training, and developing machine learning models. So I have already briefed you about what are machine learning models. And when we want to train them, even for that, we can't code it. Everything we can't code. So we have ready-made library available with us, and we can make use of it. And it's then you will find only few lines solving our purpose of designing a program or preparing a code for AI application, machine learning. And use cases, building and training neural networks, deep learning applications, computer vision, NLP, then machine learning model development and deployment. So all these, in all these areas, it is being used. And then for web development also there are available. So Flask and these two are available. They help in developing the web applications. Okay. Web development libraries. And these are essential Python libraries. Why I have mentioned them? Because these libraries are extensively used. So you should know them very nicely. Okay. So you should be very well into learning NumPy. I mean, you should be well versed in these libraries. So NumPy, Pandas, Matplotlib, Seaborn. Seaborn we can skip, but even we need to manipulate statistical information, and Scikit-learn. So for numerical computation, data manipulation and analysis, data visualization, Matplotlib, statistical data visualization, and for scientific and technical computing. And then I have searched and I have brought out this for you, that where actually you can use in which applications, physics problem solving. So mechanics and dynamics, there you can make use of NumPy for vector operations, SciPy for solving differential equations, Matplotlib for visualizing trajectories. Yesterday you have seen we have used it there, and courses and libraries like SymPy and can be handled symbolic computation. So SymPy is one of the library, and for symbolic computation, that is for deriving equations of motion and solving mechanical problems analytically, they are there. So once you will start using them, you will come to know. And then electromagnetism, in that we can use SciPy, NumPy for numerical simulations of electromagnetic field. So tomorrow, I think you are going to use this for your magnetic field and electromagnetic field applications. And Matplotlib and Seaborn, they will help in visualizing field distributions and potentials. Libraries like Astropy may assist in handling astronomical data related to electromagnetic phenomena. And the quantum mechanics and statistical physics, there we can again use SymPy, and of course for symbolic calculations in quantum mechanics, and SciPy aids in solving Schrödinger's equations and simulating quantum systems. So please try all of them once you become expert. And Pandas can organize statistical data from experiments, and Seaborn can visualize distribution and statistical properties. So these are few fields where we can use them. And the next is the benefit of using Python libraries, though we have already discussed them in the beginning, but still let us revise it. Okay, revise itself means, of course. So reduce development time. So pre-written codes are available. Developers can focus on core functionalities, meaning whatever problem is in hand, looking at solving it, rather wasting their time in reinventing the field, which is already there. Why to reinvent? It is there, just use it at ease. Then improved code quality. Yes, because libraries often comes with extensive testing and documentation. I've never seen any library giving wrong results. They are being tested very drastically. I mean, to very deep layer, they get tested, and they are also documented properly. So they really ensure the code reliability and maintainability. So we don't have to worry about this. So it definitely improves code quality, because when you are writing the code, you are bound to make mistakes. There will be so many bugs, and then you will keep on removing them. At some other part of the program, again, you are writing, making mistakes, removing it. You are using libraries, you don't have to worry about the codes, bugs, because bugs are not there in that much portion of your coding. Then increase productivity. Yes, developers can achieve more in less time because we can utilize our time using these well-established functionalities. And access to specialized functionalities. So libraries provide access to advanced algorithm tools that would be time-consuming or complex to develop from scratch. So that I'm being repeating again and again. So this last point is very crucial. I mean, very much helpful. Crucial in the sense if we are required to do it. So we don't have to do it. We just relax and do it. So much fun is there in using these libraries, right? And this is large, actually, they get installed. So we don't have to worry nowadays. But even if you should know that there is the PIP manager. And the name of the PIP manager came from Python package index. So actually it should be PPI, but they have taken I between what can we do is their wish. Just accept it. So pip install, here, look here. Pip install library name. So if you write pip install numpy, then numpy will get installed and it will be ready for use. But you don't have to worry. When you are using Colab, it is already there. All libraries are accessible. So this is an when we set our private environment, in that case, we have to use this. You don't have to, you are using public. So don't worry. Then in conclusion, yeah, so let's conclude with this. I'm not concluding the lecture, please. You have to be with me till I finish data file and CSV file, but we are concluding on library files, libraries. So library files in Python provide powerful tools. Actually, I wanted you to read it. Aishwarya, are you there?
Yes, ma'am.
Can you please read it? Is it readable?
Yes, ma'am, sure.
Oh, please read it. Read it.
Library files in Python provide powerful tools for solving a wide range of physics problems efficiently. By level-dragging numerical computation, data handling, and visualization libraries, physicists can streamline calculations, visualize results, and gain deeper insight into physical phenomena. Understanding and utilizing these libraries effectively can significantly enhance problem-solving capabilities in physics. Python's rich ecosystem of libraries empowers physicists to tackle complex problems efficiently. By leveraging NumPy, SciPy, SymPy, Pandas, Matplotlib, and Seaborn alongside domain-specific tools like AstroPy, PyDS tool, researchers can conduct numerical computations, handle data seamlessly, and visualize results effectively. Understanding these libraries enhances the ability to analyze experimental data, simulate physical phenomena, and derive meaningful insight in physics research.